Ya, Assalamualaikum. Morning.
Waalaikumsalam doktor. Good morning.
Salam doktor. Good morning.
Dah scan ke QR code?
Dah.
Doktor.
Dah, doktor. Okey. Okay, so hari ni topik kita ialah sample size determination, and kalau kita sempat kita sambung dengan sampling method. Okay. Okay, sample size. Sample size is part of the in the research method actually. Okay, but I touch a bit inside this, even though this is just this is statistic lecture, but I touch also on the sample size. Okay. Sample size and sampling method actually is inside the research method. Okay. Okay. So sample size is we have to calculate sample size. Okay. Sample size is actually just a guide. Okay, just a guide to we want your research to be scientific and statistically sound, so we have to calculate sample size. When we calculate sample size, okay, we need the minimum required sample size in the study. Sample size meaning that how many patient, how many record you want to collect, then that one you have to calculate. Do not be fussy about numbers, okay? Right, so this sample size is just a guide. A guide. For example, you are required to take 100. Okay, so that means your sample, when you go and collect sample, you just need to take 100. Okay, so it's not ethical. Okay, unethical if let's say you take more than required. Okay, because for example, you take blood, okay, or you do X-ray. Because X-ray, you know, there's a radiation, right? So you are supposed to take 100 only, but you go and take 200. So another 100, extra 100 is unnecessary. You expose them to the X-ray, okay, to the radiation. So that's why sample size we need, okay, because for us to how we can estimate how many sample that we need to take in our study. Okay, sample size may or may not be able to calculate. Yeah, I can divide it into 3: compulsory, unnecessary, and also no clue. Okay, compulsory is where you have a testable hypothesis. Okay, testable hypothesis, that means, for example, I'm going to compare radiation between X-ray and CT scan, for example. So there's a testable hypothesis. Then it's compulsory for you to calculate. Okay, unnecessary. Okay, some studies you need to follow guideline. For example, animal study. Okay, animal-based study. Animal-based study because it limits. Okay, okay, majority sample size are small. Okay, how many rabbits you need to take? So there's a guideline already. How many rats you need to take? So there's a guideline already. Okay, you cannot take more than that. Okay, because animals, they restrict a bit. Okay, sometimes no clue. Okay, because when we want to calculate sample size, we need to have information from the literature. Okay, okay, when we need to take some parameter from the literature, and we can calculate sample size. Okay, so some study, for example, you claim that your study is the first in the world. Okay, so there is no literature on that particular topic yet. So you don't have any clue to calculate sample size. So then, if like that, there's a guide. Okay, how many sample size that you need to take if you don't have any clue. Sometimes cell line study, those who are working in the lab, okay, involve the cell line, the plate, that maybe no clue to calculate sample size. Okay, sample size depends on study design and available information from the literature. Okay, you have learned on study design already. Okay, so let's see after this, we reflect the sample size and also together with the study design. Okay, so quality or strength of the statistical inference depends largely on the size of the sample selected. If you remember our confidence interval formula, right? Confidence interval formula, okay, CR equal to estimate plus minus K into standard error, right? So sample size is inside there. Okay, standard error equal to standard deviation divided by square root of n. So sample size, that n is a sample size. If sample size small, your confidence interval will be wide. If sample size you have adequate, that means large enough, then your sample size will be, your confidence interval will be precise. So it depends largely on the sample size you select. So that's why sample size is actually very important in your study. Okay. So this is just a diagram. Okay, I want to show you if we relate the sample size together with the study design. Okay, so we learned already in the study design as interventional study and then observational study. Observational can be divided into analytical as well as descriptive. Okay, so basically this is the common one. Actually, in sample size, there are many types of calculation of sample size. Okay, the one that I'm going to share with you is just a common sample size, how to calculate. Okay, for example, we use two means, we use single mean, okay, single proportion, two means, and also two proportions. Okay, that's I'm going to share with you, 4 of them only. Okay, but if let's say you do a validation study, you want to validate some measurement too, you want to validate a questionnaire, yeah, that one different. Okay, it's not in this kind of flowchart. Okay, that one is separate. For example, you are looking for correlation okay, between two numerical variables. Okay, same thing also. Okay, not this one. So actually, sample size is very big scope. Okay, I just take the one that is common only. Alright. Okay. If we see the descriptive one first. Okay, the descriptive one. Remember descriptive, we are looking for the prevalence and also incidence, right? Okay. Cross-sectional study, if let's say incidence, a prospective cohort. Yeah. So descriptive also can be, for example, you are looking at the you want to determine what is the mean cholesterol level or what is the mean of radiation. Okay, if those who are exposed to CT scan, for example. So if you're just to determine the mean, okay, just to determine the prevalence, then we use under descriptive. Okay, if you are interested on the numerical, then it will be single mean. Okay, if you are interested on the proportion, then we use the single proportion formula. Okay, when we calculate sample size, it depends on our objective. Okay, objective of the study. Okay, first objective is you are looking at the prevalence, okay, to determine the prevalence of obesity among primary school children. Second is to determine the associated factors of obesity among primary school children. Then you have to calculate one by one. Okay, so the first one, because this is just to determine the prevalence, the prevalence is in the proportion, right? In terms of proportion, then we use single proportion. Okay, and then you calculate the second one. Okay, calculate second one. So after that, you have calculated already objective 1 and 2. Then you take the largest sample size. Okay, largest sample size. Okay, that's how we calculate sample size. Okay, and then that is descriptive. Then there's descriptive. Then, if let's say we go to observational study, observational study, you have learned already four common under observational study: prospective cohort, retrospective cohort, case control, and cross-sectional. Okay, prospective cohort. Okay, prospective cohort, we are interested on the exposure on the disease, so that's why you can see a proportion of disease among exposed group versus proportion of disease among unexposed group. Okay, let's see the example after this. So like this one, okay, this tree study design, we are more interested on the exposure. Okay, so that's why exposed in the disease, exposed in no disease. So basically, this we can use two means or two proportion. Sometimes we can use more than two means or more than two proportion. Okay, either independent or related. Okay, so same thing also for experimental or interventional study. Okay, if parallel, RCT, the parallel one. Okay, parallel because it's independent sample, right? So we use independent means or independent proportion. Depends on your outcome. If your outcome is you are looking at the, for example, blood pressure, then it's mean. If you are looking at the either smoking, yes or no, okay, then it's a proportion. Okay, if crossover, because this is dependent sample, then we need to use the related or dependent mean or proportion. Okay, so it depends on the study design also. Okay, all right. So far, okay.
Okay, Doctor.
Okay. So before we go to the sample size, okay, there are three things that you need to know. One is study design. Okay, study design you have learned already. And then we want to know on the mean. Okay, you have learned already mean, and the third one is proportion. So mean, what kind of mean? Okay, you have a single mean, two or more means. Okay, and then proportion also same thing. Okay, so that one, the three things you need to know. So I've introduced you already in the introduction that day. What is numerical, what is categorical. So if numerical is under, if you will report in means, if let's say categorical in terms of proportion. Okay. Okay, so there are four approaches to calculate sample size. Okay, formula, okay, statistical software, sample size tables, and also nomogram. Okay, but okay, nowadays we formula also less used, okay, because we have software. Okay, software, the one that I asked you to download, power and sample size APS software, and also AP info software, that is a free software. Okay, there are many free software actually. There are many software, even the apps also. Okay, in the phone also you can download the apps. Okay, sample size table, this is a long time ago. Okay, 1978, 1970s. Okay, they use sample size. Okay, there are many students when it come out. Okay, when it comes to the writing proposal, they go and search the sample size table. Okay, a sample size table, and they put in their proposal. But the reference is 1970 plus, so not relevant anymore. Okay, so now you have to update yourself. Don't use this kind of table. You have to go for proper method. Okay, either formula or the software. Software is actually comes from formula. Okay, that's why they develop the software based on the formula. Okay. Okay, this one I mentioned already. Okay, I will talk on these four things. Okay, single mean, single proportion, two means, and also two proportions. Okay, these two software that I asked you to download. So any problem? I think all software, right? Especially the AP info.
Okay, Doctor, no problem.
Okay, good. Okay, so okay, let us go to the first one. Okay, single mean. Okay, single mean. Single mean, like I said just now, the objective is, okay, I'm looking, the researcher is interested, okay, to determine the mean level of the radiation in CT scan. Radiation, is it in numerical? the yes, right. Okay, so you are interested to know if let's say you use CT scan in certain disease, for example. So what is the mean of the radiation? Okay, so that is your objective. Okay, that's your objective. So when you know already, okay, my objective is I'm interested on the mean, then you need to calculate using single mean. Okay, your objective is just descriptive. There is no any comparison. That means you are not interested to know a comparison between two groups or between more than two groups. You just want to determine mean only. Okay, then we go for single mean. Okay, this is a single mean formula. Okay, not difficult. Z, standard deviation, okay, divided by detectable difference. Okay, detectable difference. Okay, so and then you square the whole thing. All right. So this z value, okay, the z value is based on the standard normal distribution. Okay, z value standard based on the standard normal distribution. Okay, it depends on your for example, you set your alpha at 0.05. Then your confidence interval will be 95%. 95%, right? So your z value will be 1.96. It fixed. Okay? It fixed. If let's say 95% 95% CI, then your z value will be 1.96. So it fixed. Okay, and then standard deviation. Okay, this is population standard deviation we take from literature. Okay, standard deviation we take from the literature. Okay, when you search literature, okay, preferable you take the value from the local one first, because for example, maybe radiation is not much different from other country, but for example cholesterol, it may be different from our country Malaysia compared to, for example, overseas one, okay, UK or US. So they may be a bit different. Okay, so maybe they are more healthier that side. Ours is a lot of obese people, so the mean cholesterol is become higher, standard deviation also become higher. So when you want to look for the standard deviation from the literature, look at the local publication first. Okay, if you cannot find from the local, then look for the regional. Okay, South Asia, okay, the similar state, Thailand, okay, Singapore, okay, regional one first. But if really cannot, then you don't have any option. You can look for Asia, for example. Okay. So standard deviation. Okay, for example, you found a few standard deviation from few literature. So which one that you need to choose? Because, for example, in Malaysia, there are already a few studies have been done before. Okay, so there are few standard deviation. So which one you need to take? You take the bigger. Okay, take the biggest one. Why you take the biggest one? When you take the biggest standard deviation, your sample size also will be big. Okay, you take bigger standard deviation, your sample size also become big. Okay, so standard deviation from the literature. Then we go for this is detectable difference. Okay, the estimated difference from the population mean. Okay, this one it can be determined from the literature. This is estimated. Okay, that means don't take directly from the literature. What does it mean this one? For example, you are going to determine the mean radiation. Okay, so you found the mean inside the literature. Okay, you found the mean. Okay, so you estimate your the difference of mean from the literature and from your study. Okay, estimate. Okay, for example, okay, I think the difference is not much, maybe 2. Okay, so you estimate. So this is based on the expert opinion, the estimation. Okay, from the expert opinion. But if really you don't have any idea, I don't have any idea in my country what will be the mean of the radiation. I don't have any idea. Then you can apply the concept of effect size. Okay, we have the concept of effect size. Okay, so what is effect size? Okay, before that, do you have any question on the single mean? Not difficult because this is very straightforward.
No.
No, huh? Okay. So if we cannot find from the we don't have any idea about this detectable difference, then we can apply effect size formula. So what is effect size? Okay, what is effect size? What is the concept of effect size? Effect size refers to the magnitude of the effect under the alternative. Sorry, this is wrong. Alternative hypothesis. Okay, so never mind about this definition. I just want to show you the formula. Okay, effect size formula equal to detectable difference divided by standard deviation. Okay, effect size has been suggested by this Cohen. Cohen is actually a statistician. Okay, Cohen suggests effect size can be divided into three: small, medium, or large. Okay, if you think that your effect size is small, okay, small, right? Then you use the 0.2. Okay, so that means you use this formula. Okay, you use this formula. Okay, effect size equal to detectable difference divided by standard deviation. Okay, so you change the formula, become like this, because we are now looking at the detectable difference. Okay, we don't have any idea on the detectable difference. So use this formula. Detectable difference equal to effect size multiplied with standard deviation. Standard deviation you know already. Okay, because standard deviation from the literature just now, the one that you found for this formula. Okay, for this formula, you found already the standard deviation. Okay, so you just put in the formula. Okay, standard deviation, you know already from literature. Effect size, you decide. You want the small effect size or medium effect size or large effect size. Okay, then if let's say, of course we prefer a small effect size. So okay, I want small effect size 0.2. So 0.2 multiplied with your standard deviation, then you got the detectable difference. So this detectable difference, put in the formula, put in this formula, then you can calculate your sample size. Okay, is it okay?
Yes, okay, doctor.
Okay, so now let's go to the example. Okay, example. Okay, this is example 1, single mean. A group of researchers want to estimate the mean systolic blood pressure of Malaysian female. Okay, so you are interested, your objective is to estimate the mean systolic blood pressure. Okay, in the literature, okay, the standard deviation found is 20 millimeter mercury. Okay, this is from literature standard deviation. Okay, researchers wish to estimate the true mean to within 5 millimeter mercury with 95% confidence. So that means your Z value is depend on this 95% CI, 95% confidence. And then the true mean, this is the detectable difference. Okay, this is the detectable difference. So standard deviation 20, detectable difference is 5. Okay, your Z value is 1.96. Okay, depend on this 95% CI. So put in the formula. Okay, put in this formula, you got 62 women. Okay, you got the 62 women. Remember, when you got the sample size, you have to add 10 to 30% dropout rate. Okay, what does it mean by dropout rate or response or non-response rate? Sometimes in your study, okay, there's missing. For example, you take your study from the medical record, okay, from the registry, for example, okay. Sometimes that one you will not involve the patient directly. Okay, so that means in terms of response rate, of course you cannot measure, right? So but you need to consider whether in terms of the response in the medical record, whether is it full complete or not. If not complete, that's why we need to add that 10 to 30% response rate, non-response rate. Okay, in the medical record, for example, there are many missing, right? Okay, sometimes this medical record you can find it, another medical record cannot find it, so that's how we add. Okay, to accommodate the sample size. Okay, so we add usually is 10 to 30. So this one, it depend. Okay, on your study. If let's say you use survey. Okay, survey response rate is very low. Okay, so you can add your the non-response rate. Okay, so if you expect 80% of response rate, then how to calculate? That means you calculate your sample size 62 divided by your response rate 0.8. Okay, so equal to 78 women. Okay, so that means your predetermined sample size will be 78 women. Okay, all right, is it okay, single mean?
Okay, Doctor.
Okay. All right. Now we go to next one. Okay, single proportion. All right, single proportion. Okay, single proportion. Okay, for example, prevalence study. All right, prevalence study. So prevalence study under observational study. Okay, under observational study, we are looking at for example, prevalence of prostate cancer, prevalence of anything. Okay, prevalence of tuberculosis. Okay, so you are looking at the prevalence. So prevalence is in terms of proportion, right? So that's why we use single proportion. Okay, we use the single proportion. Okay, so this is single proportion formula. A single proportion formula, not much different from just now. Mean, because we use the standard deviation. So that's why you come out as standard deviation just now, right? But for proportion, it's a proportion. Okay, P is a proportion. Okay, so N equal to Z, same thing. Okay, and then divided by, same thing, the detectable difference. Okay, square it. Okay, and then P is a proportion. For example, if let's say prevalence of TB, then P will be proportion of those who develop the TB, okay? And then 1 minus P, okay? So this is the formula for the single proportion. Okay, before I forget just now, single mean, I asked you to download the PS and also Epi Info. For these two software, the single mean calculation is not available. Okay, single mean calculation is not available. Okay, that's why you have to calculate manually. Okay, but in other software, okay, for example, if you download apps, there's one apps we call it N4 study. Okay, N, small n, 4, number 4. Okay, if you can download, you can download in your phone. Okay, when you do the proposal later, that one you have the single mean, single proportion, two mean, two proportion. That one also you can use. Okay, that one also free. As far as I know, free. Okay. All right. Now let's go single proportion. Okay. So proportion. Okay. Same thing. P comes from literature. Okay. P comes from literature. Z value, same thing, based on the standard normal distribution. Okay, this icon is for precision or detectable difference. Same thing. Okay, how much estimated difference between population and sample. Okay, P is proportion of prevalence. Okay, from the literature. Okay, P is from the literature. So remember, literature, you take the recent, local, right? If let's say you don't have any idea about this P, okay, statistician suggests to take 50%. Okay, 50%. That means your proportion will be 0.5. Okay, So is 50% yes or 50% no. Okay, if you don't have any idea about the prevalence, okay, then you can estimate. You can take as a 50%, so 0.5. So 0.5, it gives the bigger sample size. Okay, that one if you don't have any idea, right? Okay, so this is from the literature. Okay, and then precision. Precision is you can set. Okay, this is the estimated. Okay, the precision. Small precision, you will get bigger sample size. Usually precision, we set the difference between population and sample. We set around 5%. The most it can be 10%. Okay, that means 0.1. Okay, that the most can be 10%. The difference between population and sample. Okay, so generally we set as 5%. Okay, 0.05. Okay, but if let's say you set as 0.05, your sample size is too big, then you can set up to 10%. Okay. Alright, so this is very useful, okay, in cross-sectional study to determine the prevalence. Okay. Alright, so this is the scenario. Okay, a local health department wishes to estimate the prevalence of dental caries among children under 12 years of age in its locality. Okay, so you are looking at the prevalence of dental caries. Okay. So how many children should be included in the sample so that it may be estimated to within 5 percentage point of the true value with 95% confidence. Okay, so that means this estimated to within 5%, this is your precision. Okay, this is your precision. Okay, 95% CI, because it reflect your Z value after this. And then it has been estimated that the prevalence of dental caries among children was 20%. This is from the previous literature. So that means your proportion will be 0.2. Okay, we can put in the formula. Okay, just put in the formula, you got the 246 sample size. Remember, you have to add the 10 to 30 dropout rate. Okay, you have to add. Okay, so after adding, depends on you. Okay, adding the dropout rate, it depends on the researcher, how many you want to add. Okay, so this is by using formula. Alright, let us try using EpiInfo. Okay, you can open your EpiInfo. Alright, EpiInfo. So this, okay, the feature for EpiInfo, actually this is the older version. Okay, even though still EpiInfo 7, but this is not the latest version. Okay, the one that you have, you can see there are tables right in front there, right? Square box, if I'm not mistaken.
Yes.
So you click the stat card. Can you find the stat card?
Yes.
So click that one. Okay, it's the same thing. It's a method of appearance, only different. Okay, so stat card. Okay, look at the sample size and power. Go to population survey. Okay, can you get this one?
Yes.
So it's not the same. Only thing, the appearance in front, they make it more nicer, like by drawing that box. Okay, but it's actually the same thing. Okay, population size, don't bother. Okay, expected frequency is your proportion. Is your from the previous literature just now. Okay, we put as that 20%, right? So here they want the percent, so 20%. Confidence limit is 5%. Okay, then you put in this formula. If you see the sample size, look at the 95% CI. That means 246. Okay, 246. Okay, let us try. Okay, I will open my I will open the EpiInfo. Okay, My AP4, so older version. Okay, so stat card, sample size power, population survey. Okay, so population size, don't bother. Expected frequency in the literature mentioned 20%. Confidence limit 5%. Okay, you can see design effect. Okay, at the end of this lecture, the sample size lecture, I will mention to you what is design effect actually. Okay, design effect. This is reflect with the sampling method. Okay, it is related to sampling method. For the time being now, just ignore first. Okay, just put 1 first. Okay, so your sample size will be 2, 4, 6. So this is the sample size 2, 4, 6, and then you add the dropout rate. Okay. Okay. Another example. Okay, another example. All right. Estimate the proportion of Malaysian males who smoke. Okay, what sample size is required to achieve 95% CI of width plus minus 5%? Okay, that is 5% of the true value. Okay, so a study some years ago found approximately 30% were smoker. Okay, so your prevalence will be 30%, your precision will be 5%. Okay, so this is follow the formula. Okay, so if your response rate is estimated at only 75%, okay, then add another 25% for the data collection stage. Okay, so that means your response rate you estimate of 75% only. That's why you have to divide it by 0.75. Become 431. Okay, so if you software, okay, this is by using software. So you got 323. Okay, is it okay? Single proportion not difficult. Okay, not difficult. Is it okay? Any question on the single proportion? So far so good. You are now at your proposal writing, right?
Not yet, Doctor.
Not yet. When is your proposal writing?
Next semester.
Oh yeah, I forgot. This subject is supposed to be second sem. Okay, never mind. Good. That means you learn earlier. Okay, so that means when you write a proposal later, you can apply some of the things. Okay. All right. Next one is two means. Okay, two means. We have learned already just now single mean, single proportion. So that means if you just want to determine the mean level or you just want to determine the prevalence, then we use the descriptive one. Okay, single mean as well as single proportion. Now, if let's say you want to compare, okay, you want to compare between two groups, for example, okay, your research question is there any difference of radiation between CT scan and MRI, for example? Yeah, I just simply give example. Okay, is there any difference of radiation between X-ray, between chest X-ray and CT scan, for example? Okay, so your outcome, you are interested on the mean because it's radiation in mean. Okay, and then you want to compare between two groups. Okay, since your outcome is mean, then you are going to compare between two groups. That's why we use two means formula. Okay, that's why we use two means formula, right? Okay, so this is the formula for two means. Okay, right? 2 multiplied with standard deviation, square it. Okay, divided by, this is same thing, detectable difference. Okay, this is z value for the alpha. Okay, and this is for the beta. All right. If you notice it, what is the difference between this formula and single mean formula? What is the difference?
Square. Only Z is square.
Sorry, what is the difference? Z alpha is level of your alpha level of significance. Beta is what? You have learned already beta. Beta is what?
Power.
Beta power. What is power? Beta is not power. 1 minus beta is power, right? Beta is type 2 error. Okay, so your if you set your beta is 0.2, then your power will be 80%. Okay, why in this formula we is involve power? Why in single mean there is no power? Why? What do you think? Why it involves power in this formula, in two means formula, but why in the single mean formula there is no power involved? In single proportion also there is no power involved. Why? What do you think? Any idea? Because it's double, two means. Why double? Why do you think double? Because there are two groups. You are on the right track, so two groups. What is that two groups? Because there is a what? No, not today. Two group correct already, but what is that? When you have what? Yeah, you have a comparison. You have, in other words, you have the testable hypothesis. In descriptive, we don't have hypothesis. Okay? When you do proposal letter, be careful. Your objective, you are looking at the mean to determine the mean level of radiation among patients, among cancer patient, for example, using the CT scan. Second one is to compare, okay, to compare the mean of radiation between prostate cancer and breast cancer. I'm not sure correct or not, but I just say example, right? Okay, so that is your research objective of your study. When you do hypothesis, the first one, there's no hypothesis because that's just a descriptive. Only the second, your hypothesis will be only one. Okay, your objective, there are two, okay, but your hypothesis only one. Because first one is just to determine level. Okay, you are not comparing anything. So we don't have any hypothesis. Remember, hypothesis is you are looking at the comparison at whether they are association or not, whether they are difference or not, right? So there must be a comparison. Okay, in other words here, beta, the power is not applicable because there is no hypothesis in a single mean and single proportion. Is it okay?
Okay.
Okay. So that's why you can see in two means there's a power involved here. Okay, so this value Z alpha and Z beta, this value are fixed. Okay, if you see the lower part here, if you set your alpha 0.05, okay, then your Z value will be 1.96. Okay, if let's say you set your alpha 0.01, then your value will be 2.58. Okay, if let's say you set your power as 80%, 80% power usually in the observational study. If you do interventional study, RCT, community trial, then we up a bit our power, become 90%. Okay, so that means if 80%, okay, your beta you set as 0.2, then your Z value will be 0.84. Okay, if your beta is 0.1, then you set as 1.28. Okay, so the rest are the same. Okay, only thing is standard deviation. Okay, standard deviation, remember you have two groups now. One is the radiation in the CT scan, another one is standard deviation in the radiation in the MRI. You have two means now, right? Okay, two means. So that means you have two standard deviation. So which standard deviation you need to choose? For example, you found in the literature, you found both standard deviation in the CT scan and also the MRI. So which standard deviation you need to choose? Okay, you can choose either one. Okay, you can choose either one. But of course, prefer to take the bigger standard deviation. Why take bigger standard deviation? Then our sample size also will be bigger. Okay. Alright, then we have precision. Okay, the detectable difference. This is just now the detectable difference is between population and your sample. Okay, this detectable difference is between two groups. Okay, so what do you think, based on your expert opinion, what is the difference of radiation between CT scan and radiation in MRI? What is the difference between these two? Then it is your estimated one. You can based on your expert opinion, okay, from your supervisor or from your reading, okay, so you can estimate the difference between these two. Right, so put in the formula, then you got your sample size. This sample size is for per group. Okay, per group. So that means your sample size later, you have to calculate with 2. Okay, because you have two groups now. So you have to calculate with 2 and then you add the dropout rate. Okay, just now single mean, single proportion, we no need to multiply because that one is, we don't have any grouping. So that is for the single one only. Okay, but for these two means, two proportion, what you calculate is for each group. Okay, for each group. So you want to get the total, you have to multiply with number of groups. Okay, is it clear? Okay, this is RCT. Okay, let us go to the scenario. Okay, this one quite long. Okay, what I want to say here is, okay, this is a new antihypertensive drug is going to be tested. Okay, so they select those who have systolic blood pressure more than 160 and also diastolic blood pressure more than 95. Okay, basically they select those who are hypertension. Okay, so a new antihypertensive drug, they want to compare with the current practice. Okay, so this is RCT. So they have two groups. One is the current, one is the new one. Okay, and then the difference, okay, the difference between these two, when you use the new drug, when you use the current drug, the difference of the BP between these two is 10 millimeter mercury. Okay, the difference is 10 millimeter mercury. And then the standard deviation, okay, they take from the literature, standard deviation is 20 millimeter mercury. Okay, maybe this one is from the current one because a new antihypertensive not available yet because it's just tested, right? So this is standard deviation from the current treatment. So 20 millimeter mercury. Power, they set as 90%. Alpha is 0.01. Okay, so put in the formula. Okay, alpha is 0.01, beta is 0.1 for 90%. Detectable difference is 10. Standard deviation is 20. Okay, your Z alpha 2.58, Z beta is 1.28. Put in the formula, you got 119. Okay, for example, 120. Okay, this is per group. Okay, per group. Then you multiply with 2, so you need 240. Okay, before that, you still need to add the dropout rate. Okay, so that is your sample size. Okay, that is your sample size. Alright, this one we can use software, okay, that is a PS software. You can open the PS software. Okay, let us open PS software. Okay, so this is PS software. I don't know what version now. Okay, this is old version already. A long time I did not update already. Okay, version 3.12. Okay, so just click continue. Okay, right. So this is the, you cannot download PS software. Why? Web crash.
Dia kena website lain Doktor.
You kena website lain tapi PS juga kan?
Ya.
That's why saya kata jangan guna link yang saya bagi tu. Yang tu version berapa tau. Okay, you can actually okay, for example, okay, this is vendor bill. Okay, this one, the first one, vendor bill. Okay, this is from this, from, oh, this one cannot. Is it this one you install?
Yes Doktor. Software Informer.
Okay, so you click from the software informer. Okay, but this is from the DuPont. Okay, developed by DuPont. Okay. Alright, so you got this. This is the PS software. Okay, so PS software you have many here. Okay, that's how you can see if let's say you use survivor, different, okay, regression, dichotomous, mentalism. There are many actually here. Okay, now we use two means. Two means you later you will learn on the statistical test. If you say you want to compare your outcome will be the numerical, you want to compare between two groups, then you need to use independent t-test. That's why here is t-test. So click the t-test. So what do you want to know? Okay, I want to know sample size. Okay, paired or independent? Is it paired or independent, this one? You have two different groups. Is it paired or independent? Paired or independent? Independent is related. Dependent is related. Related meaning, for example, I want to measure my blood pressure before and after. I'm taking the new antihypertensive. Okay, so that means you have a single group only. Alright, you measure their blood pressure. After that, you give the antihypertensive, the new drug. And then after some time, you measure again the blood pressure. So they are from the single group, from the same group. Then that one is called paired or related sample. Okay, but now we have two separate. One is group for new antihypertensive drug. Another group is for current treatment. Okay, you have two separate. So that one we call it independent sample. Okay, independent sample. Okay, so we click independent. All right, then you can put the value here. Okay, alpha just now 0.01. Okay, power. Remember, this is power. Okay, not beta. Okay, power that means 90%. So don't write 0.1 here. This is power 90%. Okay, this is, what is the symbol here? Sometimes, I'm not sure what symbol is this. So you can click the blue color. Just click the symbol. Then it will come out this help. So that one meaning a difference in population mean. So the difference. So the difference here is 10. Standard deviation is 20. What is M? M is the ratio. Okay, M is the, if you see, you can read the M. M is the ratio of control to experiment. Okay, M is the ratio of control to experiment. Okay, some study, very difficult for you to get the test. Okay, that's why you increase your control. All right. usually we increase 4 times, then that means you take more control in terms of your test. Okay, but if not, we just put 1. Okay, just put 1 here. Okay, 1. That means it will balance. Okay, just now 120 one group, and then the group also 120. Okay, and then you calculate. Then you got 1 to 1. Okay, 1 to 1. Your just now is from the formula is 1 to 0. Software always a bigger estimate than formula, but don't worry, you'll be okay. Okay, for example, in your proposal, you calculate using software, then you print screen this software, put in your proposal. That means people aware already. Okay, you are calculating your sample size using software. So if let's say they calculate using formula, the value is different, it's okay because you show already to them I'm using software. Okay, if let's say you use formula, then you put the formula and write down your calculation. Okay, if you don't use formula, just print screen this software, any software that you use, print screen, put in your proposal. Okay, that one should be okay, right? So you got already 1 to 1. So this 1 to 1 is per group. Remember, at your dropout rate. Okay, any question?
Doctor, can you
Yes.
explain that why M we put as 1?
Okay, M is the ratio between a control and test. Okay, in this example, M is the ratio between current treatment and new treatment. Okay, our ratio is, okay, I want it to be same. That means I want it to be equal number between current and also new treatment. Okay, in certain case, for example, you have difficulty in taking the test group. Okay, your test group, sometimes the number of test group is very small. Then you have to increase your control, because when you increase your control, it's actually you are increasing the validity of the study. Okay, so that's why you increase. Okay, so you can increase. For example, I want more in control. Okay, but you must have justification why you want to add more control. Okay, for example, 2. Okay, 90, this 90 will be 90 tests. Control will be just multiply with 2 because your ratio is 2, right? So control more. Control is 180. Okay, but if there's no any justification why you want to add more control, just leave it to 1. Okay, this is the ratio between control and test, not the ratio of test to control. This is ratio of control to test. Okay, is it okay?
Okay, Doctor.
All right. Okay. Okay. All right. At the end of study, okay, you required to calculate, to add, to select the sample, to get the sample 1 to 1. Okay, per group. But at the end of study, I managed to get only 80 patients. The total patient that I got for each group, I get only 80. Okay, original sample size that you need to take is 1 to 1 with the power of 90%. Now your sample size, you got the final one, cannot already, you don't have any time already, your sample size you got only 80. Do you think the power it will be reduced or it will be maintained as 90%? Can you understand my question? Reduce, right? Okay, original power 90%. With 90%, you need to have a sample size 1 to 1 per group. Now your sample size, you got the final sample size after the data collection, everything, you got only 80. Okay, 80. Do you think your power will be maintained as 90% or reduced? Okay, it will be reduced. So how to know when your sample size you got less than your required sample size? You have to calculate, we call it post hoc power. Okay, we have to calculate post hoc power. That means you have to calculate back your power of the study, because your power of the study will not be the same anymore. It already reduced. Okay, so how to calculate post hoc of study? Okay, so what do you want to know? You want to know power. Okay, power. Okay, so this is same thing. Alpha, all these parameter is the same. Now your sample size become 80. Okay, become 80 per group. Remember, this is per group. You calculate. Your power now become 71%. Okay, from 90%, your power already reduced to 71%. Okay, sometimes power is become very small because you cannot get sample size anymore. Okay, very small. Then it will affect your results. Okay, that means you have to be careful when discussion. You have to discuss. Your power already reduced. Okay, so when people want to take the result, it must be very caution a bit. Okay, because your power of the study already reduced. Okay, if you have sample size, you got the 1-to-1. Your sample size, you final sample size also, you manage to get all the patient, then no need to calculate post hoc power. Okay, post hoc power only applicable if you got your sample size less than your required sample size. Okay, you need 1-to-1, but if let's say you got 1:110, for example, not much difference, so still acceptable. Okay, if let's say there's a big difference, then you have to calculate post hoc power. So post hoc power we have to write in the methods and also discussion. Okay, that is post hoc power. All right. Any question on the two means and also post hoc power?
Doktor,
Yep.
Doktor, saya tak clear lagi pasal dropout rate tu.
Dropout rate. Okay. Okay, I explain again. Okay, dropout rate. Dropout rate, we need to add dropout rate in our study. Okay, because sometimes, okay, for example, in a trial, okay, you measure baseline and then you measure, you have to follow up patient again. Sometimes patient did not turn up. Okay, so that means there is a dropout already there. Okay, so we want to overcome this problem because we know already in a trial for sure there's a dropout rate. Okay, in when we take the sample, even from the secondary data, okay, from the registry, from the medical record, you can find there's an empty, right? Sometime in the questionnaire, people don't answer. So you want to overcome this. Then you have to add, when you calculate sample size, we add the dropout rate or non-response rate. Okay, we add. Okay, we add. Okay? Your sample size, okay, when you calculate, okay, when you calculate, you have to add. Right? The formula for calculating is, okay, the formula for calculating is actually your sample size. Okay, how to calculate the final sample size? That means your sample size divided by 1 minus, I say, for example, the symbol is your dropout rate, D, for example. Okay, so you think that, okay, in my study, I'm doing questionnaire. Okay, this is dropout rate or non-response rate. I'm doing questionnaire. I think that, for example, I use survey by using email, right? Okay, dropout rate is very high. Okay, non-response rate is very high because not many people will entertain your email. Okay, so maybe I think that 40% our got non-response rate. Okay, 40%. So 40%. So that means you calculate sample size 120, for example. Okay, right? So I estimate, okay, since I do survey based on the previous study, previous literature, the non-response rate will be 40%. So that means what is your response rate? 60% only, right? Okay, so this is non-response. Huh? So 1 minus non-response rate, 40%. So that means you calculate 120 divided by 0.6. So this is your sample size. Okay, 120 divided by 0.6. Okay, this is the correct way to calculate, to add the non-response rate or dropout rate. Okay, some people they calculate like this. N equal to N multiply. That one wrong. Multiply, for example, that one wrong. Okay, this is wrong. The multiply one is wrong. Okay, the correct one is this one. Okay, N divided by your 1 minus dropout or non-response rate. Okay?
Doktor,
Yep.
yang 0.4 tu assumption ke?
Your own. You predict your own. Okay. I'm doing. That is survey. Okay. 0.4. For example, I'm going to collect secondary data. Okay. I'm not involved with patient directly. Okay. I just want to take from the record only. But you have to anticipate that your record will not be complete 100%. Okay. Alright. Okay. Then I think that, but maybe not much different because this is registry. So registry people will complete it. Okay. But to be on the safe side, I need to add 10% dropout, 10% non-response rate. Okay. So 10% non-response rate. So that means your sample size divided by 0.9. That it depends on researcher. Okay. In what, how you collect your data. Okay.
Okay, tapi dia ada limit tak untuk assumption tu?
Dia tak ada limit.
Oh.
Mostly people between 10 to 30%. Okay. But if you can justify, okay, from the previous study, for example, survey just now. Okay. Non-response rate for survey is quite high. If quite high. So if you want to add more than 30% also, if you have justification, is acceptable. Alright?
Okay, doktor, thank you.
Okay.
Doktor.
Yep.
Doktor, saya faham pasal value of dropout rate tu. Yang okay, yang formula doktor tulis N sama dengan N per 1 minus G ni formula apa?
Yang ni lah to calculate.
Yang ni to calculate dropout rate tu.
Sebab you kena add kan. You have to add. Okay, this, for example, this example. Your calculation is 120 per group. Okay. You have to add 10 to 20%. So how to add this value? So using this formula. So N equal, for example, okay, I decided to take 20%. So this is 20% of dropout rate. So 120 divided by 1 minus 0.2. So 120 divided by 0.8.
Okay.
Okay.
Okay, faham, terima kasih.
Alright. Other question? No. Okay. So if no question, okay, can we continue with another one that is two proportion? Okay, two proportion. Okay, two proportion. Okay, before we go to examples or formula, all right, I just want to show a bit this one. Okay, in this two proportion, we are going to calculate using formula and also software. Okay, there's a big difference between formula and software. This just in terms of the symbol only. Okay, two proportion, remember two proportion. Okay, for example, our research question is, I'm looking at the association between smoking and heart disease. Okay, I'm looking at the association between smoking and heart disease. Okay, my study design will be cross-sectional study. Okay, remember cross-sectional study is you are interested on the exposure, right? So smoking in the heart disease, smoking group in the no heart disease group. So you will have two groups. You will have interest, that means in the smoking group. In the heart disease group, you have control in the no heart disease group. That's why you can see interest and control. Alright. Interest, the symbol is the same between formula and software. P1. Okay. Interest. Control, the symbol a bit different. P0 in the software, but in the formula written as P2. But actually, it's the same thing. This is for control. Okay, I'm telling just the symbol only different. Okay, but the calculation is the same. Okay, P0 in the software, P2 is in the formula. If you see in the software P0, that means this is for control. Okay, if you see formula P2, this one also for control. In the control, okay, the proportion for control we take from the literature. Okay, we take from the literature. The interest, our interest, this is based on the expert opinion. Okay, expert opinion. That means you can estimate, okay, based on your expert opinion. Alright. Okay, in the two proportion, there are three common formula. Okay, this is the first one. Okay, the formula for proportion is quite long. Okay, we call it pocok formula. Okay, so this is quite long, but basically this is the P1 is the interest, okay, proportion in the interest, plus with this is from the control, okay, P2, and then this is minus, and then you add same thing, Z beta plus Z alpha plus Z beta, and then square it. Okay, so P1, that means proportion in the interest group. P2 is proportion in the control group. Okay, and then you just put the information that required, and you calculate the sample size. Okay, this is the first formula. This is the second formula. Okay, second formula. Basically, if you use any kind of formula, so the result will be more or less the same. Okay, if you have option use software, then go for software. Okay, formula of course it quite long, so it takes time. Okay, so this is the second formula. This is I call it modern formula because we use this symbol. Okay, I forgot already. This symbol is represent what is one. Okay, we learned in AdMax before. Okay, this formula. So I call it modern formula. And then we have another one. This one also quite long. Okay, this is also quite long. Right. So that is formula. Okay. Okay, now let's go to first example. Okay, first example, this is under RCT. Okay, under RCT. Okay, patient are randomly do a randomization, okay, into two groups, treatment A and treatment B. Okay, they want to know whether using that treatment, what is the disease recurrence? What is the disease recurrence by using that treatment? Okay, treatment A is standard. Treatment A is standard. Okay, treatment B is a new therapy. Okay, in the literature mentioned that by using treatment A, there will be 35% of disease recurrence. Okay, there will be 35% disease recurrence. Alright, but for treatment B is a new therapy. Okay, new therapy. Okay, of course, disease recurrence you will estimate a bit lower. Okay, because new therapy, right? Okay, if let's say you estimate 45%, for example, what is the purpose of doing study? Because we want the disease recurrence to be less if use new treatment. That's why you estimate it to be less, 15%. Okay, so this is your estimated of disease recurrence by using new therapy, 15%. Power of the study, RCT, we set as 90%. Alpha will be 5%. Okay, now remember back, we have P0, we have P1. Okay, which one is your interest? Which one is your control? Which one is your interest? Which one is your control?
P1 is B.
Control. Sorry, P1 is?
B.
Yes, P1 is B, P0 or P2 is A, treatment A, because it's the control, right? Current treatment, standard treatment, right? Okay, so proportion, proportion of disease recurrence in the treatment A will be 35%. Estimated proportion of disease recurrence in the treatment B will be 15%. Okay, will be 50%. So put in the formula. Okay, this is a formula. This formula is use the third formula. Okay, third formula. So we got 96 per treatment group. Remember, you calculate two means or two proportion if for single group. Per group, right? So you have to multiply with 2. So 96 per group multiply with 2 at the dropout rate. Okay? Then you got your the final sample size. Okay, now let us use software. Okay, use software. Okay, so this is no more t-test. Remember, t-test is for mean, right? So now is dichotomous. Okay, dichotomous. So what do you want to know? Sample size. Mesh or independent? Is it mesh or independent?
Independent.
Yeah, independent, right? Because they have two groups, right? Two separate groups. Treatment A and treatment B. So independent. Okay, this is the study design. Case control or prospective. This is RCT. RCT is it is considered as prospective because we are going to intervene, right? And then we measure again. So prospective. How is the alternative hypothesis expressed? We are using two proportion. Okay, that means we have the proportion A and also B just now. Okay, this one uncorrected chi-square official exact. Okay, this one we choose as uncorrected chi-square test. Okay, uncorrected chi-square test. Okay, alpha 5% just now. Okay, power 90%. Okay, P0. Okay, P0 equal to P2 just now, right? Proportion of disease recurrence in the treatment A. Okay, that will be 35%. Okay, P1 is the estimated proportion of different disease recurrence in the treatment B. Okay, new treatment we estimate as 15%. Ratio here is the same thing as just now. Okay, ratio of control to case. Okay, we want it to be the same, then just put as 1. Okay, calculate. Okay, same 96 per group. Okay, 96 per group. Alright, any question? Any question?
No.
No, huh? Okay.
No.
Alright, good. Okay, that is RCT. Okay, RCT, clear cut. RCT not much different. Okay, RCT is clear cut. Now let us go. If let's say our study design is prospective cohort. Our design is prospective cohort. Okay. Okay, if you remember this diagram, okay, this diagram is exposed because prospective cohort, this is not happened yet, right? So direction to the future, you are in the middle. So exposed, okay, we are interested to know disease in exposed group and disease in unexposed group. Okay, so this is the scenario. Okay, very long scenario. All right. Basically, this is we are looking at the okay, in terms of incidence rate between two communities. Okay, incidence rate in unexposed community A is 1 per 1,000 population. In the community B exposed, okay, estimated to be 15 over 1,000 population. Okay. Community A is unexposed. Okay, unexposed. So, this is your P0. Okay, the control. Unexposed, right? So, exposed one will be P1. Okay, P1. So, P1 will be 15 per 1,000 population. Okay. Power 90%. Alpha will be 5%. So, what is your sample size? Oh, this one I forgot again to change. This is not estimated. P0 is from the formula from the literature, so not estimated. Just mark this one. Okay. Right. P0 is from the literature. So 1 per 1,000 population, so equal to 0.001. In the community B, okay, 15 per 1,000, so 0.05. So calculate sample size, you are 8 for 8 per group. Okay, 8 for 8 per group. Right, then we put in the software. The software we got 8 for 9. Okay, not much different, only one different only. So 8 for 9. So that is the calculation for the prospective cohort. Okay. Actually, it's not much different. Okay, it's also use the proportion. Okay, but from this scenario, you need to detect. Okay, which one is P0, which one is P1. Okay, which one is P0, which one is P1. Okay, this one clear cut because this is unexposed. When unexposed is from the control. Okay, this is exposed, of course, from the interest, from the interest. Okay. Okay, same thing also for case control. Okay, case control, we are interested on the case. Okay, we are interested on the exposed and non-exposed. Okay, sometimes, okay, you can also use the odds ratio. Okay, in case control, we can use odds ratio. In the prospective, sometimes they give you the relative risk. Okay, you can use also. There's option inside your PS software. Okay, inside your PS software. Okay, inside the PS software, you can use, instead of two proportion, you can use relative risk. Okay, depend. Okay, sometimes you cannot get the estimated P1, but in the literature, there's a mention about the relative risk. Then you can estimate from there. Okay, get the relative risk, put inside here. So not it's still acceptable. Okay, if let's say case control, we use odds ratio. Okay. Okay, so this is same thing. All right, this is about the eating jelly beans and developing rubebitis. Okay. Okay, 20% population eat jelly beans, and if let's say develop rubebitis, it becomes 30%. Okay, so your P0 will be from the population 1.2. The interest one will be 0.3. Or you can also use the odds ratio. Okay. So not much different. Put in the formula, put in the software, you got the sample size. Is it okay?
Okay.
Okay, Doctor.
and then post hoc also I mentioned already about post hoc. Okay, it's actually the same thing as a t-test just now. If let's say you got the less from your required sample size, then you have to calculate post hoc power. Okay, post hoc power. Okay, this is example for cross-sectional. Okay, for cross-sectional. Okay, for cross-sectional. Okay, alright, like this example. Okay, this example to identify the associated factors of smoking among adolescents. One of the factor is paternal smoking. Okay, paternal smoking. Okay, so paternal smoking in the previous study among non-smoker is 20%. If you notice here, there is no, it gives only for non-smoker. Non-smoker, that means P0 or P1? P0, right? Okay, so this is P0 because control, non-smoker. So, they don't give any value for P1. Okay, what do you think of P1? That means paternal smoking among smoker. Do you think that it will be higher than 20% or less than 20%?
Higher.
Higher, right? So we estimate it to be higher. Okay, because paternal smoking among those who are non-smoker is 20%. That means those you need to estimate the paternal smoking among smoker group. Okay, if you think that paternal smoking is one of the factors, then your P1 should be higher. Okay, so we estimate. Usually we can estimate, just now I mentioned around 10%. Okay, if you don't have any idea, you can estimate around 10%. Okay, we can add, like in this example, I make it 35%. Okay, 35%. Okay, then, so this is from the expert opinion. So you got the sample size. Okay, sometimes the tricky part is they give like this. I don't give any value. Okay, I don't get any value for P1. You estimate yourself. Okay, if you estimate 15%, this is less. That means you think that paternal smoking is not the factor for the smoking because you give 15% only, less than the 20%. Then this is not correct. Okay, because you are looking at the potential associated factors. That means you think that paternal smoking is one of the factor. That's why you make your P1 increase. Okay, than the 20%, higher than the 20%. Okay, is it clear?
Ya, doktor.
Okay.
Doktor,
Yep.
P1 tu boleh berapa-berapa je ke?
Boleh berapa-berapa je. Tapi, if you notice here, right? If you see, you can open your PS. Okay. Remember just now, I mentioned the difference around 10%. Okay, for example, we take the... Okay, cross-sectional just now. In this PS, they have only case control and prospective. If let's say cross-sectional, you just choose case control. Okay, you just choose case control, and then we need to proportion. Okay, 0.8. Your P0 just now is 20%. Okay, P1, I put 35%, right? Okay, so calculate. Now you say that I want to increase. That means the detectable difference between P0 and P1 will be bigger. Okay, I want to increase, for example, 50%. Your sample size will be very small. Remember our formula? Our formula, the difference down there, right? If difference is big, your sample size will be small. So be careful a bit. Of course, it's your right what you want to put for the P1. Because it's estimated, right? But be careful a bit. You must justify. If let's say the difference is too big, your sample size is small. If let's say, for example, I think not much different, 25. Okay? So your sample is 1000 plus. Okay? Small difference, bigger sample size. Big difference, small sample size. Okay?
Okay.
Alright. This one just ignore. Comparative, just ignore. Okay, this one that I want to explain a bit. Remember just now in the epi info, there's a word of design effect, right? Okay, this one is actually, okay, you will learn in the sampling. In the sampling, you will learn cluster and multi-stage sampling. Okay, in the sampling method later, you will learn cluster and multi-stage sampling. If you use this kind of sampling method, okay, cluster and multi-stage, if you use either cluster or multi-stage, you have to consider design effect. Okay, you have to consider design effect. Cluster meaning, for example, you take from school. You take from the school, you don't do any sampling, you take the whole class. So it's considered one cluster. Okay, so they are homogeneous. Right, for example, standard 4. So everybody standard 4, everybody because in one class, so the when you divide the class, I don't know nowadays, but last time we divide the class based on our exam performance, right? If let's say you are good, you are in the first class. Okay, if you are quite poor, you're in the lower class. Okay, so the homogeneous sample is there. That means you are surrounded by more or less the same people. You are at the same age, all right? Your IQ also more or less the same because you are grouped in one class. Because of that, that's why we have to consider design effect. Okay, to overcome this homogeneous thing. Okay, design effect. So design effect, how to overcome? We have to multiply our sample size with design effect, okay, between 1.5 to 2. Okay, for example, you calculate the sample size. I got 100 per groups. 100 per groups. Okay, so that means after adding everything, after adding the dropout, so you need 250. This is for both group. You have to multiply, for example, design effect. You are using cluster. You are using cluster sampling. So I want to I choose 2. So your sample size will be 500. Your sample size, if you use cluster or multi-stage, your sample size will be very big. Okay, will be big. Alright? So that's what it means by design effect. Alright? If you see from your PS just now, right? Okay. Design effect. Okay. I use cluster sampling. So I want to multiply my design effect will be 2. Okay, 2. How many cluster? Okay, how many cluster? This is how many cluster, for example, school. How many school you want to take? I want to take 3. So your cluster will be 3. So your sample size 95% just now. One cluster is 164. That means from one school you need to take 164. Total sample size is 492 for 3 cluster. So that is what it means by this design effect and also cluster. Okay? Any question? We have finished our sample size. Any other question?
Doktor,
Yep.
yang formula N pasu N bahagi 1D tu kan? Dia valid untuk 2 means je ke?
Tak. Ia applicable untuk semua sample size.
Oh.
Semua sample size.
Lepas tu yang dekat single proportion.
Okay.
Saya tak faham yang. Lepas tu ada yang dekat solution dia tu kan. Dia cakap if the response rate is estimated at only 75, then add another 25%. Apa maksud dia?
Sekejap. Okay. Okay, this one. Okay, response rate is estimated at 75%. Okay, this is what study? This is, okay, you are looking at the proportion of male who smoke. That means basically you will go and collect the data by using a questionnaire. Okay, so you estimate that only 75% will respond from your questionnaire. Okay, 75% will respond. So that means there are 25% who will not respond to your questionnaire. You estimate only 75% will respond, so your non-response rate will be 25%. Okay, so when we calculate sample size, okay, just 3 to 3 divided by 1 minus your non-response rate. Non-response rate will be 25%, so divided by 0.75. 0.75, so that's why you got 431.
Oh.
Boleh?
Tapi dia punya estimated tu boleh je kan kalau kita nak buat macam 80 ke apa.
Boleh.
Maksudnya setiap orang dia lain-lain lah. Dia boleh estimate.
Lain-lain, betul.
Oh, okay.
Okay? Any other question? Any other question for sample size?
No, Doctor.
No, huh? Okay, so if no question, we finish our sample size determination. Okay, is it heavy for you?
Quite heavy.
Quite heavy. Okay, don't worry. Alright. When you do your proposal later, some of you will apply this thing. I don't say more. I will not say that all of you, because some of you you will not calculate sample size. For example, you do a phantom, no need to calculate sample size, or some of you do questionnaire, then different sample size. Okay. So it depends on your study later when you do proposal later. So a good thing you apply, you learn first this SEM. Okay. So next SEM you will apply in your study. Okay, like study design, sampling method, all this you apply later. Okay, so good thing you have pre-knowledge first before your proposal writing. Okay. Okay, so I don't think I can continue with sampling method. I think it's heavy already for you. Okay. Or you still want to continue?
No.
No. Okay, I know, heavy already. Okay, so don't worry. All right. Our sampling method, I will continue after your SEM break. Okay, SEM break, you will have a test. Okay, you have a test after your SEM break, 15 December. Okay, so that means I will not include sampling method. Okay, your test will be up to sample size only. Okay, that's one.
Okay, Doktor. Format macam mana?
Format, how many questions I'm not sure yet, but format is MCQ and also SEQ. Okay, format like your final exam, you have MCQ and SEQ. Okay, 1 hour test only. Okay, 1 hour test only.
Okay, Doktor.
Alright, so this topic you have to learn lah from the beginning introduction till your sample size. Okay, and after that, we will continue with the sampling method. Okay, so that means your sampling method will not be in the test one. Okay.
Doktor,
Yep.
about assignment?
You all worry about assignment. Assignment I told you, right? Assignment, when you start doing your statistical test, I teach only start with numerical. Okay, numerical data analysis, categorical data, that one will start statistical test. There's no point I give you now because you haven't learned anything yet.
Oh, okay.
Don't worry. Why you all worry about assignment? Don't worry. Okay? Don't worry. Slowly. Read for your test first. Okay, so if that's all for now, no question. Okay, inshallah I will see you again after your sem break. Make sure read for your test one. Okay, any question you can just put in a WhatsApp. Okay.
Okay, Doktor.
Okay.
Thank you, Doktor.
Assalamualaikum.
Thank you, Doktor.
Okay, Assalamualaikum.
Terima kasih, Doktor.